chapter number 10, which is about quantitative data analysis to using SPSS, statistical package for social sciences, abbreviation of SPSS. Okay, these are the content, data analysis, coding, okay, outlier, extreme value. Okay, let's discuss one by one. Gathering the data, ready for data analysis. Okay, first, number one is data coding, data entry. You must know how to code the data. Okay, we'll tell you with many examples, with support of example, I mean. Today's chapter is most belong to practical work. Rather, okay, combine some of theory, most of practical work. Anyway, SPSS. I have dummy data for you people, for your training, for your better understanding. At least you can understand. Okay, wait. I'm telling you what other things. Data collection sheet. Okay, I'm not going to share with you people. Open SPSS fair. How about your data collection? My dear student, how about the data collections? Are you collecting the data? You can see this one. You can see this document, Word file. Okay, now you also can see the data sheet. Understand one by one. I have to discuss. See, my dear student, first, this is the one paper which I published, the fear of COVID-19 with the role of avoidance behavior and self-resilience. Okay, abstracts, introduction, literature review, fear COVID-19, okay, discuss and propose the hypothesis. See, this is the hypothesis, I propose the hypothesis. Now the fear of COVID-19 and the avoidance behavior, I discuss the relationship between two variables. And then this is the hypothesis, I propose this is a hypothesis, okay. Oh, this is a conceptual framework, or we also can say theoretical research framework. This is the research framework. See here, fear of COVID-19, one, avoidance behavior, mediation, this is the moderation, this is the IV, and these all three are dependent variables. Okay, anyway, methodology. Here I discuss about the sampling. Okay, the total 500 respondents were collected. Okay, my sample size was a 500. Okay, then sample size larger than less than 500 appropriate. I also give the references. The scale of the study, I also discuss mean questionnaire, fear of questionnaire from adopted from this study, scale of okay, hypervigilance taken from the trust was key study. Okay, I also given the detail. Then I use the SPSS, smart PLS and SPSS as well. So this is my data analysis. Now we will discuss today about the data analysis and the finding. Here is the some demographic descriptive statistics, gender, age, educations of the study. In this case, 75% male, 26 this in age. I also describe the descriptive statistics. And in our two-day lecture, I also will tell you how to discuss the demographics and how to conduct the descriptive statistics analysis. Okay, then here is a smart PLS for the model tested hypothesis. Anyway, for this analysis, for this analysis, I use questionnaire. This questionnaire. Hope you can see the questionnaire. See here, the respondent. I give your age. Okay, how many responded are their age between 20 and 30 years and 30 to 41 years. I segregated in this one. And our gender, how many males participated in my research and how many females participated in my research, and their educations level, and then my responses about my IVs and DVs and coronavirus fears. This is the fears. First, first my DV, IV, and these are the questionnaire. These are the questions which are mainly fear, coronavirus fear in the community. And the next other variables is the hypervigilance, and these are the items are migrating hypervigilance to using Likert scale, five-point Likert scale. And here helplessness, another variables, and the measure of resilience, another variables. Okay, then these questionnaire I used to collect the data. I use that collect the data. Now is the form of the collection of the data here, like this here. See. First respondent, this is the first respondent, this is the second respondent, third, fourth, five, six, seven. Okay, first respondent, seventh respondent was the male, and his education, his age was 31 to 41 years, and qualification was PhD. And the responses, okay, 1.3, these are the responses he recorded. Okay, he recorded and interpreted. This data will come up, okay, in this form. Now this data sheet, how we import in the SPSS, the main things is SPSS. Now, okay, we did the process one by one. Now second data, okay, let this one convert in the coding. It's better to convert in the coding, I mean coding, how we can code. Suppose here anger questionnaire 1, 2, 3. Rather writing this one atom 1, giving the whole statement, just give the code. I mean, see, I already given the code because see here, fair. My first study was my first variable is fair. Rather giving the whole statement, it means these all 8 variable are migrating fair, community fairing. Just I give the code 1. Okay, fair 1, fair 2, fair 3, fair 8. Okay, and second variable you can check second variable. Second variable is about hypervigilance. I give the code hypervigilance. See here. Hyper HVG 1, 2, 3. How many questions are hypervigilance? Maybe 4. Let's check. Not 4, more than 4, I think. See here. Okay, 10, 11, 12. Oh, 12. See? Hyper 1, hyper 2, hyper 3, and 3. And the other one is helplessness. I give the code help 1, help 2, help 3. Eh? Okay, these are the codes. Oh, mine is the another function, the main function. You must focus on this one. This is a very important lecture. No, I'm going to open the SPSS. You must have a SPSS software in your system as well, by the way. Then I will tell you which analysis you have to run on SPSS. There is 2 and 3 method to enter the data into SPSS. It's better to record your data on the Excel and Excel sheet import into the SPSS. Then you can run the required analysis. See, I'm going to share this SPSS as well. Yeah. Now you can see the platform of the SPSS. This is the SPSS software. Okay. Data view, and no, we don't. No, I don't have anything because I didn't import. First thing is might be you here must you write okay pair 1 or might be gender okay, then give the this is the numeric width is okay, label give the gender, okay, this is the male and female, label give the label. Oh, values also can give the values here, okay, for male, okay, label, oh sorry, value 1 and male add, then value 2 female, okay, then okay, label also can write gender, okay, and the columns, right columns, each and everything here, okay, and then Meyer, which is obviously nominal Meyer, this is a nominal Meyer, okay, that's, so you can see next one here, see here gender, if you response, then response 1, second one is 2, second respondent, third respondent is 1, 2, 3, 4, okay, different la, different, okay, and the next variable is education, suppose education, this is also numeric with, okay, give the education and filler here, education, okay, label first one for different, okay, a diploma, just write the diploma. Now this is a manual, you have to enter manually, but another easy method I'm also going to tell you, the another easy one, it's better, delete, okay, delete, clear, very simple, clear, it's better. If you can see, go here, must go new data, oh why I just opened the new file, no, oh sorry, I closed, mistake. And second thing is, the Google survey, you just download the file in Excel and that file you can import directly into the SPSS. See here, okay, open, sorry. Okay, where is the file? I must know. I know where is my file. My file is the D, okay, D and UUM teaching and research methods. Yeah, this is SPSS. Okay, so here we'll ask you give the file name. Okay, all files. Now you can find the all files. This data sheet I'm going to import here. Okay, open. Can you see? Can you see the process? Yes, student. Can you see the process?
No, sir.
Cannot?
No, sir. Yeah. You just said this shit.
Okay. Okay. Wait. Oh man, sorry. Okay, now it's sharing. Yeah, again. I'm going. See, now you can see the platform of SPSS. And you must go here. Okay, open and click on data. Then you must know where is the data. I know my data is in the D and UUM teaching. You can see? Can you see? Such method SPSS. Okay, now you can see. Then this one here. All files. This is my file. This is my file. Okay, and open. And click. Now you can see. Okay, rather putting so many effort, now you can see the whole variables. See one by one. You can see the whole variable one by one. Yeah. Data view. Now you can see the data view. Here, male, female, female. Yeah. Also see the responses which we received or collected from the respondent. Understand? This one is a fair one, fair two variables. Got it? This process is done. Import of the data into the SPSS is done. Now, let's come back onto the slides. Data coding, I already told you how to code. Okay, data entry, I already, e.g. SPSS, how to enter manually, I also tell you, and also I also guide you how to import the Excel from Excel data into the SPSS. You also can see. And some of things, some of editing data, some of maybe missing values, and some of the outlier. Outlier is not similar data, mean outlier. This can be the outlier out of your required data. See here, if suppose 55 here, suppose here is 5 or my 45. So this is an outlier, or might be minus, or might be 0. It's also outlier. Okay, because not in our range. You also see, or might be no, here is this is a missing entry. Once you import the data, you must see the data. Okay, there is no outlier and there is no missing value. Oh, this is the original response. Got it, my dear student? So these slides belong to these things. I will tell you how to remove the outlier. Okay, the very simple one, suppose here is even outlier or the missing value. Suppose here is a missing value. What should we do? Just write 999. Okay, even outlier 33, just remove and write 99. Consider as a missing value. This issue you must tackle in this strategy. Then how this is a see another thing. You can see by physically you can see, okay, there is a missing value. If you cannot see, how you can see there is a missing value or not? Or you also can see through the analysis here. You can check, analyze, reports here, descriptive, frequencies. Okay. Import all out here, import all into the variable side, statics. Pie chart, different things. Okay, wait. cut point percentile. Mhm. Okay, just mean, first mean. Let's see, check first. You can see here, my dear student, here. Very simple. Frequencies here, the missing. You can see missing values. Missing. Can you see this one? Here. This one. Here, missing. See, okay, in gender, no missing value here. Oh, here in part one missing value. One missing value. One missing value. Here in fair 7, one missing value. 8, two missing value. Understand? Okay, you didn't find in gender or here, or maybe fair 1 is one missing value. To make sure how many is okay. So for your practical, is this software is working correctly or have some issue? Let's check intentionally. Okay, suppose fair 1 now, I'm considering missing value 2. Before 1, now how many? Let's see. Let's check again. 1. Analyze descriptive frequency, simple. Okay. See here, missing value. Okay, done. Understand? So you can identify, okay, in fair 1, there is a missing value, 5. Now, how to remove it? Just go to the fair 1. Fair 1. See here, this is one missing value. 999. Go. Here. 999. Okay. Because we saw, okay. 999. Oh, here is also 999. Okay, here. 999. Sorry. Done. Okay. Done. So this is a method how to deal the missing values as well. I also taught you. Transforming data. One more thing. You must you must transfer the data first. IV and DV, because these are the atoms 1, 2, 3, 4, 5. So how they all variables should represent the fair variable, the transfer of them, make the one variable. So here, okay, compute, right, fair. COVID, fair COVID, right, like this. You cannot give the space here. Now is a fair 1. Okay, plus. Now how to calculate? Please see. Plus fair 2, fair 3, 4, fair 5, fair 6, fair 7, fair 8. No, divided by how many items? How many items? 8, right? Calculate, execute. Now you can see the average of variable. Here, data. See, this one is our variable. Okay, the complete variable. Rather giving the items. No, another variable, because I'm going to my I will not calculate the whole variable. Just I will analyze two variables, IV and DV. Okay, you have a 3 IV and 1 DV. You will do that one. Transfer first. Compute variable. Okay. Another variable, yeah, helplessness. Okay. I'm writing help. Help. This is my, suppose my DV. Suppose this is my DV. Yes. We so many variables. Okay, no problem. We have to calculate. And divided by how many? 18, right? How many? 18. Okay, calculate. Incorrect variable name, either the name is more than 64 character or it is not defined by a previous command.
Forget to press plus at help 9.
Oh, where? Yeah.
Help 9, number 9.
Okay. Yeah, good. Here? Okay now? Check again. This is a, advantage of this software. Will give you error. Okay, if you did anything wrong. See, another variable already calculated. Now, this is one of way. IV, another one is our DV. You must calculate because all items. Now here in fair, we have all 7. See here, all variables details from here to 8 is now we merge in one variable because these all items are miring fear of COVID-19, right? And from here, helplessness, from 1 to 7 items miring helplessness. So we merge in this one variables. Okay, representing items. Now let's move on another one. We already transfer the data. Getting a field for the data. Okay, nominal, ordinal, we already know here. Okay, let's check the field. It's automatically will come. See here. Others are, this is the gender, your age, education, or the nominal. Other one is this one is the scale, because in the numbers, like not in the category number, we can fill the gap because we use the Likert scale, right? We use like Likert scale. Okay. Then very simple. Very simple. Okay. Just wait for a while, my dear student. Okay, my dear student, let's come on the point. Okay, so now we have to convert this one, all are scale, because we know, see scale. Scale, we know now, scale, because numbers. Okay, you can convert. Basically, my main concern is here, I already converted in scale. Anyway, okay. Can you hear me? No, we are going to see the frequencies. Okay, frequencies. Descriptive stats. In descriptive stats, we will see the normality of the, okay, one by one, normality of data. Where should we go? Okay, frequencies. See here, in my paper, if you can see, in respect to descriptive status, gender, age, and calculation were taken as a demographic in study. The current study, 73% males, 60 to 26% of females are participated. Moreover, 59% responded from the here area. And how we get these demographics data? How we can get? Let's go. Analyze descriptive frequencies. Okay, my dear students. Because we just need only these two, because others we don't need. Others we don't need because we are demographic analysis. Demographic analysis is related with the gender, age, and the educations. Okay, these are the gender groups. Let's go here. Okay, stats. Fertile, mean, medium. Okay, anyway, this one. Charts. Our main concern is the chart. Pie chart, histogram, or bar chart. Okay, I'm going to, yeah. Okay, percentage of frequencies. Let's discuss first frequencies. Pie chart. Okay. It's calculating. You can see the here frequencies here also. Male. Female, percentage 25%. Male, 74% participated in your survey, in your research. In respect of age, I mean 20 to 30 year age, how many percent people participated? 58. And frequencies, total number 221. Okay, just discuss in the percentage. And education also. Let's see the calculation. See here. These are the giant female. Female is how many percentage? How many percentage we can see here from here? Female, 25%. These portions, or the others are green portion, how many percent male? How many? 74%. Got it? Got it, my dear student? Understand? Okay, Samini. Okay, wonderful. Now we can move to one more thing. Wait. Descriptive frequencies, chart, and the percentages only. Let's see, percentages only. Many will give. Cumulative percentage. It's giving cumulative percentage. Anyway, our main concern is this pie chart. If you want to present in your thesis, you can present, and its description you can give from here. Okay, 25% are male, 74% are female. Might be can here. From here. See here, 25% female, and this one, and here. Okay, 31 to 40 year age. How many people? 29% related with those people who have 31 to 40 year age or between it. And other one, 10% belong to 41 to 50 years. And the only 1.6% above 50 years people participated in our research. Here, BBA and engineering, BBA are different categories. Might be you can divide it on the three only. Diploma, degree, a master, and a PhD, 4 categories only. I segregated in many, by the way, in this research. There's no need to segregate in many, by the way. Anyway, we done this research. Now, further, descriptive research. Frequency is also descriptive, describing mean, mode, medium. Next part is here. First, you must see the normality of data. Data is your normal or what? Normality of data mean your population has a one mean. Your sample has a one mean. Okay, sample has a one mean. See here, a normality test is used to determine whether sample data has been drawn from a normally distributed population within the sum tolerance. Mean population mean you're, I don't know, you people knows about the mean definition, mode, medium, anything. Okay, later I also will discuss with you normally of distribution. Let's see here. Your data should not fall from the mean. Okay, near with the mean, average. I mean, positive. If we want to measure the positive, okay, our all data is normal with the positive, rather in the negative. Okay, how we check the normality of data? Simple is that you have to memorize how to check the normality of the data in the SPSS. Simple normality for two tests. This is the descriptive stats. Please don't forget. This is a descriptive stat. Understand? So here is two tests. There are many, by the way, skewnesses and the QQ plot. QQ plot. Here you can see the all values should be near this straight line. This straight line is representing mean, representing a mean. Okay, here is a normally distributed skewness, and the cortesis value should not more than plus minus 2. Plus minus 2, these all values we have to calculate. We will calculate. I will tell you the calculation how we can calculate these two value. Okay, see here 0.3, 0.5 divided by 0.171, calculate and then see the value. Okay, now how we can run on SPSS for the normality of data. Please clear. Second step, first demographics description we already done. Now we are going to evaluate the Likert scale, IV and the DV. First, we have to check their normality of data. How we can check? Okay, descriptive stats, descriptions here. Or is more better, another other one, descriptive also, individual can descriptive, here, description explore, for the normality of data is better. Here, is dependent, this one is my independent variable. Stats, what you are looking for, percentile estimated descriptive 95%, this is the acceptance level. Plots, histogram, leave this thing, normality plots. Okay, continue. Option, let me check option. Pair wide, no, simple, 2 words. Okay, that done. Wait for a while. Result will come in few minutes. Running examine, see here. See, you can see here. Still processing, data is processing, calculating on the SPSS. I'm using SPSS 21. Now maybe available in the market 25, most latest one. Missing value also, you can see the missing value here. Anyway, this is not our main concern. Our main concern is, let's go, yeah, here. Descriptive helplessness. Let's go level later. Calculating. Too many calculation. Wait for a while. Wow, it's mean not. It's giving us a, one by one individuals. I'm not looking for it, by the way. It's too many. Wait. Analyze, descriptive, fair and cognitive. First option. Skewness and kurtosis. Let's discuss first. Skewness and kurtosis. One by one. Here. Here, first one is the skewness and kurtosis. How we can calculate? And their value should not more than plus minus 2. Please, you may help me in this regard. This one is the fair one and helplessness. First, this one I'm going to calculate. This one I can. For manual, you have to calculate. Divided 0.126. What's the answer? Can anybody help me? And this value 0.67. Divided by 0.126. Wow. My answer is 3.2. Okay, not good. It's mean my data is not normal. 0.617 divided by 0.128. Oh, 4.8. Anyway, according to me, plus minus 2. Not more than plus minus 2. This is plus more than 2. This is plus more than 2. It's when data is not normal. So for the, we require data for parametric and non-parametric. This is analysis advanced technique anyway. If we our data is a non-parametric. Now for non-parametric, we have to use the different techniques. Okay, but this one, our data should be a normal because we are going to use the parametric. And okay, this is the skewness. And how about the kurtosis? Must 0.5. I'm going to calculate here the simple. Menace, this one menace also can be a menace. 0.504 divided by 0.252. Yeah, this one is okay. Kurtosis is okay. If you calculate this one. If you calculate this one between 2 and the next one. Okay, next one is this one. I'm going to calculate this one. 1.164 divided by 0.255. Oh, also for helplessness, for COVID-19, kurtosis is okay, but helplessness is not okay. Okay, this is for your informations. Okay, if your data is fake and anything can tell us. Okay, this is the problem. Or this one is the maybe responded not, because this is a fictitious data, because I use fictitious data. I didn't use original data for your learning. Okay, this is the one how to calculate the skewness and kurtosis. Now let's move to calculate the descriptive and this one. Show plots, QQ plot. No, I didn't have a QQ plot. Normally distribution power estimations. Steam and leaf. Steam and leaf already. Plots are option. Exclude care versus in the options. Step. Estimate outliers. You also can see the outliers from here. Outlier also. Okay, outlier also can see. Only plots. You want to see the plots only. Anyway. Calculating. You also can check one by one individually. Wait for a while. It's calculating. By the way, are you around? Okay, good. See, because we know the data is not normal, so that's why it's scattered. This is a mean. It's far from the mean. It should be near with the mean. See here. Okay, QQ plot, QQ plot. This is our QQ plot. No, 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 no. Wait. Our data is so flat. Anyway, one by one. Going to use one by one. Let's see. Descriptive, explore. Only one by one. Histogram, 7. Continue. Option. Okay. Both. Yes. Calculate one by one. I'm just calculating one by one. For your easiness. Don't be confused too much. Here. One by one. It's better. My dear student, it's better to calculate one by one, I think. More better. Now you can see here. Should be mean is here, center. All value should increase here in center, histogram. This one, a QQ plot. Now, this is the correct one, by the way. This is the correct one. Sorry. So here, I know, see, most of here. Okay, good, still acceptable. Still acceptable. Just consider this one. Just consider this one. Just consider this one. Now, I'm going to run the another one. You also can calculate from here skewness and kurtosis. My dear student, see skewness and kurtosis, you can calculate. We already calculated. Now you also can calculate from here. Okay, this value first, skewness is, okay, how? 0.617 divided by 0.128. Yeah, more than 4. This is a 4. Okay, let's see in the QQ plot what is representing. Yeah. See here. Here is a problem. Here is a problem. Yeah, should be from here to here, from start to here. Okay, still we can move for analysis, no problem, still acceptable because most of on the line, most of are on the line. So that's why we are using two. We are using two criteria. According to the slide, we also can see what Tosh says here. Here is individual, or you can go for gather is okay. If you want to check their atoms, you also can go to check, but I prefer to check the whole variable is better. Check the whole variables. See here, he calculated here from here to here. Okay, 0.405. I'm going to calculate the last one, TP6. Okay, 0.054 divided by 0.340. Yeah, 0.15. Okay, still plus minus 1. It's okay. This data is more favorable. Our data have some issue, by the way, but still this is the process. But my main objective is to tell you the process. I will not tell you the how to fix it. Okay, might be after data collection will tell you the how to fix it. Okay. Now let's move for the central tendency. The third criteria, measure of central of tendencies and dispersions. Okay, my dear student, these two things must care, and dispersions. Measure of central tendency is a single value that attempts to describe the set of data by identifying the central position within the set of data. Mean. Okay, why is this is for the information, data for information, mean, medium, and mode. Then dispersion, variance, standard deviation. I mean, how far your data is, how far. Okay, we'll discuss one by one. I'm going to discuss one by one for your easiness, for your understanding. See, this is a very good picture. I think you people already took the statics in your exam, right? In your degree already, right? You already took the stats subject, business statics already. Anybody can respond? Huh? Yes. Yes, sir. Okay. So maybe you know about the medium, mode, mean, and range. Do you know about this one? If you don't know, and very simple, by the way, the number is which is the middle or the middle value. Okay, see here, 1, 2, 3, 4, 5. Which is the middle value from here? Also 9. And here 9. Medium. Middle value, all the from the old value. Mode. The more consistent value is called mode. See here, 7 is the more consistent in this value all. On above value we cannot find, in the lower value is the 11. Here is 11 2 times, but 7 3 times. So mode is 7. And the mean, the total of the number divided by, see here, all number divide 11 plus 7, average. Mean average. Mean average 11. So the range. Okay, highest and the low, this one also feels difference, basically difference. This we can use for the dispersion is with the how far differences. Okay, this one is how far from the mean. Okay, so what is the maybe average? I mean, these all values using to check the values which number are more consistent, which values are more consistent to giving us the range, difference between the largest and the smallest value. Okay, here on the one value can calculate the mean is 1 plus 3 plus 4 plus 6 plus 6 plus 7 plus 8 and divided by 1 2 3 4 5 6 7 divided by 7. It will be answer is 5. Mode, which one is a consistent number more time repeating, 6. And the medium, center 1 2 3 1 2 3, this is the center one 6. And the range, highest one is 8 minus 1 will be 7. This is the range, difference is 7. How many difference from between 1 and 8? How many difference between 1 and 8? 7. Okay, now in the range also, what is the range? You also can see this. Basically, this is belong to the dispersion. I will tell you how to calculate on the SPSS. Will tell you, no problem, very easy. And the formulas, no need to memorize the formulas, by the way. See here, the highest score in the distribution, minus the lowest score. Okay, we know. There are two sets of data about the mouse here. Okay, typing 71. Which one is the most highest one? You have to identify, by the way. Which one? Can you help me? Already 305. Here is 305 is the highest number and 66 is the lowest number. Minus 239. Okay. Is another example to tell you. No, is the here standard deviation, the variance, the main thing. Standard deviation in the variance. What is the standard deviation? Anybody can tell me what is the standard deviation? I know. We don't have so much time. Let's go. Standard deviation is the measure of how spread out numbers are. Okay, how spread numbers gap between the numbers and how far from the mean. Its symbol sigma. It denoted with the symbol sigma. The formula is easy. The square root of the variance. Wow, variance, square root of the variance. So you can ask what is the variance. Now we have to understand the variance. Variance is defined the average of the square differences between the mean. Yeah, square. Okay, mean and square difference. Later, if you want to understand that their formulas, you can see this video. Anyway, we try to understand with the example. You and your friends have just measured the height of your dogs in millimeters. My dear students, understand, please focus on this example. Okay, the heights at are 600 millimeter, this one, and the 470 millimeter, and the second dog. Third dog is a 170, and the fourth dog is 430, and the last dog is the 300 millimeter. Now find out the mean, variance, and the standard deviations. Your first step is to find the mean, because square root of mean can be a variance, and the square root of variance can be a under root of can be a standard deviation. Let's see. Now we are going to calculate with examples. Here is the mean, 600 plus 470 plus 170 plus 430 plus 300 divided by 1, 2, 3, 4, 5 divided by 5. See here, like calculations. 394 is mean. Average of height is 394. Average of height is 394. So mean average height is 34. We also can see, okay, the average mean is, this is the mean line. See, this is the mean line, this one. You can see 394. All dogs between 394, I mean, should touch 394. Some of above, some of lower, but between 394. This is the mean. Now, the variance, calculate the variance to take each differences, square it, and then average the result. Each differences between here, range, 600, 400, this one, and the second and the third dog, 76. Difference, then square, this is the variance. Now, in the under root of the variance is called standard deviations. Simple. There is any confusion here? Is any confusion? Please tell me first. Here is any confusion? Hello. Our mean is any confusion from here? Okay, our mean is, so suppose, wait. Our mean is 394, right? Our mean is 394. So if 394 and minus 600, how many difference? Divide like that, na? 394 minus 600, 206. Then other dog difference is other dog is 47. Okay, 47 minus 394, 76. Second difference is 76. And here is 170 minus 394. Okay, 224 minus 224. And this one, let's see, 300 minus 394 or 94, right? Here, okay, see 94. So it's square root. If we took the square root, it will come up positive. This one is positive. Then divided by 5. Calculate the whole and divided by 5. This is the variance. Now, under root of variance is called standard deviations. This is the sum of calculation for you. And the good things about the standard deviation is it's a useful. Now we can show which heights are within one standard deviations. 147. This is the 147. It's mean the standard 147 is this is the mean. One standard deviation mean 147 here, and this is the plus minus. This one 147 is plus, and 147 is negative, the lower side. Now we can say the all dogs can cover. We also can say 394 is mean. 394 is mean here. Can see here. 394 is mean. Okay. Average height is 394. But how spread the value? But this one cannot. See, cannot. This one is not touching the mean. The standard deviation will tell you the actual dispersion is the differences. See here, all touching. See here, all dogs are covering 147. This is the. I mean 147 is far, is divided. Using standard deviation, we have standard way of knowing what is the normal and what is the extra large of the Can see, wonderful. Now we can see which one is higher. You can see here the top. See, Rottweiler, this first dog is larger because it's going above to this thing. And Rottweiler all tall, and the Dachshunds are the bit shorter. This one, last one. Now we can see highest and the lowest level. Don't tell them, okay? Please don't tell them, okay? Any confusion? Is it understandable for you people? Anyway, these are the formulas if you want to calculate for your information. I'm giving you for your information. For the range, how to cause the largest and the very simple. Standard deviation, simple. Standard deviation for the population, and variance, how to calculate. Squared dispersion about the sample mean. These are the formula for your information. Okay, and these are the values you can see here. Mean 95% confidence interval lower bound here. Mean is 147. Is mean whole values is here. Mode 37. Variance is here. Standard deviation is this one 36. It's mean 36 plus minus from the mean. This is our mean. This is our mean. Oh, very sorry. Now, how we can calculate? Very simple. Reliability. Next one is reliability. Now we have to calculate first. Very simple. Also descriptive. This all two. Option check. Standard deviation, variance, range also can see. Mean also. And more other things is also you can calculate from the frequency as well. Frequencies. Back. Only two variables. Just here. Stat mode. Okay. Yeah, standard deviation, variance, and range. These all. 1, 2, 3. 1, 2, 3, 4. Simple. Okay. Charts we know, no need. Just calculate first this time. Now, my dear student, can see. Here, mean. COVID-19 mean is 23%. And here, helplessness 57. And the here is 25 in here. Okay, standard deviation 6.9, 6.99. And variance 44.68. And the range also, the difference between the higher and the lower. And here, difference is lower and higher. Because the responses which we collected. See, this is the statistics. You can calculate like that. Understand? My dear student, understand? You can report this table. Now, it's the last topic of today's lecture is the reliability. We already covered in last lecture, by the way. Should be here. This one should be here. Range. Advantage and disadvantage you can read. Advantage and disadvantage you can read. Now the reliability. Here, Cronbach alpha criteria. We are using Cronbach alpha criteria. Newly 1997. Should be their value is 0.7 to 0.8 and the 0.9 is more excellent. 0.9 is more excellent. You can consider here reliability analysis. Okay, these pictures also can help you. Anyway, these are reliability calculations. Wait. Sorry. Oh yeah. We are using alpha, simple. Cronbach alpha. Okay. I think should go one by one. Should go one by one. Is no is a confuse this one because individual variables. We have to check the individual. It's a problem with the. Anyway, wait for a while, please. One by one, we can go. First, we have to check the fear of COVID-19 IV. First 3 IVs, then your DV. You can check your DV. Now here, okay. Go to the sorry, regression. Yeah, correlation, maybe. Oh, scale here, scale. First, COVID-19. Then we check the other one. Mean variance, you also can get the from here. Atoms scale. Okay, sorry, other one must give the 2. Why? It's not coming. Number of items. No. No. Sorry. No. This is giving me all. No problem. Here, okay, go. First. This one is some different. Please look this one. From here, first, because how many atoms? 7 atoms. Now it's okay. Now we can see 0.9 and very good reliability. Please do this then. This is of fear of COVID-19. Now in the second other variables, scale, go here. Because must give the whole atom detail. We must give the old atom detail. No helplessness. Now we are going to see the helplessness. Yeah, this here. From here, all atoms detail. Here. Okay. Alpha, simple. Calculate. 0.89, very good. Because more than 0.07. That's all for today lecture, my dear student. Any question, please, you may ask me.